disposal of human waste? I guess in a city or a town it's pretty simple.
In the city it's, well, we probably don't put a lot of thought into the way that we deal with it in the city, but the process is still much the same. I mean, we go to the toilet, we flush it, we have a shower, we clean the floors, we empty that down the sink. Essentially, once we've done that, we consider it's all gone. The reality, of course, is that in fact it's flowing through the pipeline to the road, which we may manufacture in some cases. And then once it's gone to the road, essentially there's no consequence. It's gone to council, council then dispose of it in some manner.
Now, we talk about not putting stuff down the drain, but in the city it doesn't seem to matter.
Well, essentially what tends to happen is that effectively it's just diluted amongst a whole lot of other people's waste streams, and that's going out to the municipal systems where they break it down anaerobically and then aerobically, and in fact they're getting it back to essentially a relatively clean water that they can apply back into other dispersal methods.
So it's really just a case of volume?
It's a case of volume. Dilution, I guess, is maybe the catchword. But I'm sure they have at times some real difficulty with some of the things that householders actually put down their waste.
Now, of course, rural people don't have the luxury of a municipal system.
Well, rural people at the end of the day have got to deal with all of their waste stream from their house as an entirety. So there's no hiding what is actually done in a rural sense.
So we really are looking at a system, though, that is very similar to that of a city or a town.
Absolutely. So in this case, we are doing exactly the same processes that we would do in a municipal sense. So the first chamber, we're anaerobically breaking down primary digestion of the material that's going in there. Then it goes from there to an aeration chamber where we bubble air through the medium, and there's media in there for the microorganism to grow on, which then does much more breakdown of what you've put in there at the front end.
So that's the filter things that look a bit like pieces of string?
Yes, absolutely. The idea is to have very large surface area that the microorganism can really proliferate on, and if they do that, then in fact they're digesting their surroundings.
So where does it go from there?
It basically goes from there into a form of clarification. So what we're trying to do is to decrease the total amount of suspended solids, and any of those solids will then be captured by a device that then puts it back into the start of the process again.
So the water that's clear, where does that go?
The clear water is then pumped out through from a pump chamber, out through a filter, because clearly we don't want issues with that dispersal. It's then going out through a series of drippers into either pasture or an area that's got plantings in it, or an amenity area.
That's the purple pipe.
That's the purple pipe, yeah. So within those, it doesn't look like much. I mean, you look at the surface of it and say, oh, there's a hole. No, it's a little more sophisticated than that. There's a pressure regulating diaphragm and form of filtration inside those devices. And there's a full little dripper actually inside that pipeline.
I guess there's not too much in the way of limitations as far as what you can plant over that.
That's right. Certainly we can plant lots of plants on top, but the provision, of course, is that we don't want any of that waste stream going back into for human consumption. So amenity plantings would be normal, or actually in most cases people just simply put turf or pasture over the top of it.
Now, they're made of plastic.
They're made of plastic, yeah. As a material, of course, we rotationally mould them. They're made very, very heavily so that the compressive forces that you have in the ground won't deflect them or distort them or damage them. And the material is polyethylene, and we have an advantage over lots of other materials in that it is to an extent elastic. We put on seismic restraints, and you can see on the unit behind us there are two very heavy pieces of PVC. Essentially that stops the whole unit from lifting out of the ground if there was no liquid in there, or in fact if there's movement in the ground it will resist it.
What about maintenance? What should we do and how often?
Well, essentially as a homeowner, the important bits are that it continues to function clearly. One of the things that we can do to assist that is to make sure that the discharge filter, which is above ground, is actually always cleaned. So we do that on a regular basis, maybe every 3 months. Give that a clean, making sure that in fact there's no particulates in it. And then you'll have typically a service contract every 6 months, and the service person will come round and ensure that the air blower continues to operate at peak efficiency, because of course if we have less air going through the system, then the aerobic breakdown will proceed at a much lower rate. We want to keep the oxygen supply up, so we need those operating in good condition. And then of course the pump out or the discharge pump also needs to be checked to make sure that it's operating.
And if you do have a problem, there's a manual and you can use your phone to get help.
Yeah, absolutely. We have the manual available on our website, or in fact you can call RX Plastics and they can direct you in the right direction.